Okay, now we move to the next question, number 22. Question number 22 um, states for the reaction below, A plus B to give C plus D plus heat. Option A, theta H equals positive. Option B, theta H equals negative. Option C, theta H equals 0. Then option D, none of the above. Now, this is a quite tricky question, but it's very easy. Now, we're given a reaction and ask what is the delta H of the reaction. Now, you recall that if delta H is positive, we said heat is absorbed and it is termed endothermic. If delta H is negative, we say heat released and it is termed exothermic. Now look at this reaction to actually know if heat is absorbed or heat is released, to know if the reaction is exothermic or endothermic. Now look at the product. Focus on the product and not the reactant. Now the product, this is the product. What we have as the product, is C plus D plus heat. Now, it shows that heat is associated with the product. So if I by all means fill this container, if this is a container where the reaction occur, product is formed after the reaction. So after the reaction, C plus D is formed. If I fill this container will be hot. Why? Because heat is produced with the product. So because I have heat associated with the product, this reaction release what? Heat. And if it release heat, the term used is what? Exothermic. And delta H, the sign for delta H is negative. So option D is not correct. Option C is not correct. Option A is not correct. The answer is option B. Hope this is quite clear. So we'll move to the next question. We move to the next question. Which is number 23. Number 23. We have similar question for the reaction below. M plus Q to give R plus Z minus heat. Option A, delta H equals positive. Option B, delta H equals 0. Option C, delta H equals negative. Then option D, none of the above. Like I said, that if our delta H is positive, heat is endothermic. Like I always say, if I were you, I'll pause this question and answer myself, then play again to see if I am correct. Now, if delta H is negative, it's released. We are going to have the term used is exothermic. Now, for this reaction, the surrounding will be cooler because heat is what absorbed from the surrounding. Now, for delta H positive, the surrounding will be hot after the reaction because heat is released. To actually know this, we have to look at the product because we have to know this after the reaction has come into completion. I don't know if you get it now. Now, as the reaction comes into completion, what is available to us is the product. So it's from the product we can actually know if the reaction is exothermic or endothermic. So from the product, we have from the product R plus Z minus heat. It means that heat is being extracted. Minus heat means heat is being extracted from the surrounding. Heat is being absorbed from the surrounding. Minus heat. So that means what are we trying to say? Now, if I fill this container containing the product or the reaction, the reacting apparatus, after the reaction, it will be cold because of the minus heat, not plus heat. Plus heat means heat is released with the product. Minus heat means heat is absorbed. So the product will not what? Will not be hot. Rather, it will be what? Cold. So my delta H here will not be negative. My delta H will be positive. Option D is wrong. Option B is wrong. Option C is wrong. The answer is option A. Clear? Good. Now, if you want to really know if we are correct that this reaction absorbs heat from the surrounding to occur. For this reaction to occur, the reactant needs to absorb heat. If I take this heat across this side, I'm going to have something like this. M plus Q. Taking this across this side, it's going to be what? Plus heat. It will give us R plus Z. What does it mean? It means that the reactant, these are the reactants. The reactant absorb heat. The reactant absorb heat from the surrounding to undergo the reaction. Minus heat to the product is equal to plus heat to what? The reactant. Are you seeing it now? So it's very clear. So I'll clean the board now. So we'll look at the other questions. Question number 24. Question number 24. Question number 24 states methane was to liberate 20 joules of heat. What is the heat of combustion of methane? What is the heat of combustion of methane? Option A, we have minus 20 kilojoules. Option B, we have minus 2.0 kilojoules. Option B, we have plus 2.0 kilojoules. Option C, we have plus 2.0 times 10 raised to the power of 3 kilojoules. Option D, we have minus 2.0 times 10 raised to the power of 3 kilojoules. Now, let's solve this question. So, I'm leaving the board so you can pause and write the question before I solve. So, pause, write the question, try to solve, and see if you can solve it. Then play back to see if you are correct. Now, solution. The question states that we should look for the heat of combustion of methane. First of all, let's define what is heat of combustion of a substance. Heat of combustion, heat of combustion of methane is the heat liberated, because we all know that heat of combustion is exothermic, is the heat liberated when of methane is burnt in excess oxygen or air. Now, if it's under standard condition, we could say what is the standard heat of combustion of methane. To actually represent this, we say it is what? Delta HC. Heat of combustion of methane, heat associated, heat liberated when we heat 1 mole, or when we burn 1 mole of methane. Now, go to the question very well. They are asking us to calculate for the heat liberated when we burn 1 mole of methane. However, we are given certain amount of methane, which is in grams. When 0.16 grams of methane was burnt, the heat liberated was 20 joules. Now the question now is, what will be the heat liberated when we burn 1 mole? Now, we cannot solve with 1 mole. We cannot solve with mole because the amount of methane given to us is expressed in grams. So we have to convert 1 mole of methane to mass, or we convert 0.16 gram of methane to mole. So what do we do in this excerpt? Now, 1 mole of a substance is equal to molar mass of the substance in grams. Now, if you know this, so 1 mole of methane will be equal to molar mass of methane. Molar mass of methane, which is equal to C plus 4H, which is equal to 12 plus 4 times 1. Sumly, we are going to have what? 16 grams per mole. So we cannot use this. From the question, when 0.16 gram of methane was burnt, the heat liberated was 20 joules. Now, they say we should calculate for the heat of combustion of methane. That means when we burn 1 mole of methane, and 1 mole of methane is 16 grams. So, if I want to clean, so you pause and write. Now, I can now solve this question now. So, when 0.16 gram methane was burnt, heat liberated was 20 joules. But take note, we have to take note of the sign, but not yet. Now, heat of combustion of methane is when we heat 1 mole of methane, which weighs 16 grams. So when we burn 16, it will liberate X joules. If we make X subject, S will be equal to 16. If you punch your calculator, we are going to have 2000 joules. And like I said before, if they involve sign in the options, take note that heat of combustion is always exothermic. So it will be minus what? 2000 joules, which is equal to minus 2.0 times 10 raised to the power 3 joules. Now, is it in the option? You have to be very careful. The answer is not this. The answer is not this. The answer is 2000 joules, not 2000 kilojoules. Convert 2000 joules to kilojoules, we are going to get 2.0 minus 2.0 kilojoules. I hope you understand. What we got here is in joules, 2000 joules. 2 times 10 raised to the power 3 joules. Convert it to kilojoules is what? Kilo is 10 raised to the power what? 3. So if I remove this 10 raised to the power 3 and put K, it becomes what? 2.0 kilojoules. So option option D is wrong. Option C is wrong. The answer will come between these two. So we have to use our sense here that exothermic reaction, that combustion reaction is exothermic. Therefore, option B is wrong. The answer is option A. Clear? Good. So